Okay, guys. So next part here is into our integration. So just share my video here or my screen. So we have to integrate the following, and it's obviously a trig integration. So the four, you can remove that out. Well, you can remove it to outside of the cos, but there's no need really anyway. I'm just going to leave it here. And then I'm just going to focus here on my cos 3x. Now, it's not just a simple cos, so I need to deal with the 3. And the way to do that is you write it as a fraction. So in the front, 1/3. Cos changes to sine, and it's 3x. Now, we pretty much do the same here. The minus 3 remains. To deal with the 2 in the angle, we do a half, and then sine becomes cos, and it's 2x. So that's basically the integration done. I'll just tidy it up a little bit. So 4/3 sine of 3x minus 3/2 cos of 2x. And I'm putting in pi/6 in radians and my 0. So that's my next step. 4/3 sine of 3 times pi/6 minus 3/2, and then it's the cos of 2 times pi/6. Then I have to take that away, and from that I'm taking away the 0. Now be careful, some of you immediately put 0 for this. You just have to make sure that the 0 doesn't have a value, and in trigonometry it very often does have a value. So now for here, I end up getting 4/3. That actually becomes pi/2, and that becomes the sine of 0. Minus 3/2, that goes in there once and then 3 times, so it becomes the cos of pi/3, which is 0. Now, just double check regarding the second part. So in this second part here, I'm getting 4/3, and the sine of 0 is 0. And that is minus, that turned to, so the cos of 3/2. Oh yeah, that should have changed to a plus. Sorry guys, I'm half asleep today. I need my Christmas holidays. Okay, sorry, yeah, so they're all pluses. I should have changed them from the start. So this is plus 3/2, and the cos of 0 is 1. So just be careful there, because some of you left it out at that stage. So that's 4/3, because the sine of 0 is 1. Plus, now the cos of 0 is a half. So we end up multiplying 3/2 by half. So that's 3/4. And then we're minusing away, that's obviously 0, and that's 3/2. So when we put that into our calculator, we get 7/12. The next question down, a storm drain has a storage capacity of 10,000 litres. During a particular storm, the rate at which the water flows into the drain in litres per minute can be approximated by this function, where t is in time in minutes. So t is your time in minutes from when the storm begins. So find the two values of t at which the rate of water flowing into the drain is twice the initial rate. Now, anything to do with initial is at the beginning. So the very first thing we're going to do is have a look at what is happening at 0 time, at the beginning. So it's 175 at the beginning, but it does say find the two values of t for which the drain is twice the initial rate. So what I do then is I double that 175, which is 350. So I allow my function to equal 350. So what I do then is I bring it all to the one side, which is t squared minus 32t plus 175. I then do my minus b formula on it, and I figure out that it's at 25 minutes and 7 minutes. So that was it for that one. It was to do really with the initial rate, and initial meaning t is 0.